Right. I think there will be 2 videos for this class because it's 2020 and that's just what's happening. Okay, group 2. What did you come up with?
Hi. So our question was, what fuel does the body primarily use during long duration activities? And we discussed that this was aerobic respiration and involves the complete breakdown of glucose. Does anyone else want to add on to that?
Okay, so I didn't give you a time, but it also, the body also uses, the muscle also uses fat during long duration exercise, okay? Because what happens is you're breaking down that triglyceride into glycerol and fatty acids, and the fatty acids get broken down and provide a lot more energy for longer duration activities. Okay, so I'd like you to add that. Unless you already did, sorry. Okay, group 3.
So our question was why you wouldn't recommend a high fat, low carb diet. And that's because high intensity sports usually are pretty quick. So you're going to want more carbohydrates in your diet just because they are used for fuel more efficiently within a shorter duration.
Mm-hmm.
Whereas, as you just said, fats are really more meant for long term, or not long term, but
Sure.
like longer timed duration of a workout or activity.
Right.
So fats would be better for long duration, carbs would be better for short, more explosive movements.
Okay, or, you know, well, and we'll go over, okay. Group 4.
Group 4, we talked about anaerobic versus aerobic exercise. So anaerobic is high intensity, is made in the cytoplasm. It uses glycogen and carbohydrates. The glycogen is broken down into glucose and then broken down into a 3-carbon pruvic acid. It forms lactic acid, and this is what the body uses during this type of exercise. And aerobic is low intensity, is made in the mitochondria. It uses fat. In the presence of oxygen, carbohydrates are completely broken down. And draws on fat as well. It's broken down as 2 carbons, and the fat is more energy efficient source at this point.
Okay, and group 5.
So our question was, what happens to a runner that is running a marathon and stops sweating but keeps running, and why? So that runner is probably experiencing a heat stroke because they don't have enough fluids in their bodies to cool down their body temperature. So they will probably lose consciousness, faint. What happens is that the muscles are inefficient and produce heat when they contract. So heat is transferred to the bloodstream, which then leaves the body in the form of sweat. But if you can't sweat, then you will build up a lot of heat.
Okay, all right. All right, so I guess I have to accept these changes. Is that what I need to? Anyway, here's what I want to do now. I want to share my screen. And I'm just going to leave it like this for now. So what we're going to do now is, in the past, what I've done is I've handed these out, but we're going to discuss these answers as a class. Okay, that's what I want to do. Well, maybe I'll do my whole screen until it cuts out of me. So what we're going to do is go through a number of different activities. And we're going to talk about whether they're aerobic or anaerobic activities and what fuel is being used in that moment for that activity. Okay, and just because things are doing what they're doing today, if you will just, you know, feel free just to call out an answer. If we have too many people, I'll find something, but this is how let me just do this. So the choices will be ATP, creatine, lactic acid, carbohydrate, or fat as the primary fuel in that moment for that activity. Okay. So in the last 2 minutes of the Boston Marathon, is it aerobic or anaerobic, and what is being used for energy in that moment? Oh, I have my hands back. So if somebody, is it aerobic or anaerobic? Have a hand. What do you think? Yes, Alejandra.
I think it's anaerobic because in the last 2 minutes, I guess you will do like a sprint to get to the finish line faster.
Okay.
So you will have this sprint of energy, and you will probably use, I don't know, lactic acid.
Well, let's see, what do I have? That's what I have, that your ATPs are coming from lactic acid. It's high intensity, but it's 2 minutes, so it's not ATP creatine, all right? So you're using lactic acid because it's anaerobic. The glycogen cannot completely break down because you're not getting enough oxygen into the muscle. So you're using the ATPs from lactic acid to get across the finish line. Well, they are, I never will. Okay, how about this one? A 45-minute walk, aerobic or anaerobic? And I can see hands now, I pushed a button, so if somebody wants to raise their hand. Okay, Allie.
Aerobic because it's low intensity for a
All
longer
right.
duration.
And what's being used for fuel in this moment?
Probably fat because you passed that like 20-minute mark.
Right, so we have a magic 20-minute mark in this class, you know, for our purposes. Again, understand everybody's different, training, genetics. So it's an aerobic exercise, and the ATP is primarily coming from fat. All right, so I don't want to say competitive here. I'm just going to say cycling for 15 minutes. What are we using for energy? Is it aerobic or anaerobic? Pepe.
I think it's aerobic
Okay.
and probably getting ATP from carbohydrates.
Right. All right, so this is an aerobic exercise because it's less than that 20-minute magic mark. And when it's not high intensity, even though that's a terrible picture for, and so what's happening is in the presence of oxygen, the glucose can break down into pyruvate, and that can then enter into the mitochondria. So we have complete breakdown of glucose in this instance. So we have the energy from glucose, it forms pyruvate, it enters into the mitochondria and turns into acetyl-CoA and goes through all those reactions to produce a lot more ATP. Okay, so carbohydrate is being used primarily in this moment for energy. 100-yard dash, aerobic or anaerobic? Yes, Alejandra.
I'll say anaerobic and lactic acid.
Okay, let's see what I have. All right, so this is a 100-yard dash. So, and I'll give you the cutoffs in a few minutes. This is very high intensity, and a 100-yard dash is very short duration for, well, not Charlie Brown or Snoopy, but. And so what we're using are those ATP creatine phosphate stores. Again, and this is because of the timing, and I'll come back to that. But this is what's immediately available for, how long does it take somebody to do a 100-yard dash? It's like a couple seconds, right? I don't know. Yeah, Kevin, you're shaking your head. Justin? All right, so for our definition, this extremely high intensity exercise doesn't have enough time, is over before your glycogen stores get the message that they're supposed to start breaking down. So that's why we're drawing on ATP and creatine phosphate. Lifting weights. So I'm going to say that's also a couple seconds from what I hear. Aerobic or anaerobic?
Anaerobic.
Anaerobic, and what are we using for energy?
Carbohydrates, probably.
Let's see. Lactic acid.
Lactic acid, maybe.
If it's taking more than 10 seconds. Yeah, probably. Good job. Hiking for 2 hours on the Freedom Trail. Aerobic or anaerobic? Alejandra?
Aerobic because it's long duration, not very high intensity, and you're consuming fat.
Right. All right, so this is the diagram that tells all for your purposes. All right, although for the exam, you have it in front of you, so fortunately you won't need to memorize it. But these are the cutoff points for our purposes. Keep it, remember, everybody's different, but for exam purposes, if it's extremely high intensity, our duration is 8 to 10 seconds. And in that 8 to 10 seconds, that means it's anaerobic. And if it's 8 to 10 seconds, we're using ATP and creatine phosphate, what we have in our cells. Then as we decrease the intensity, but you can increase the duration, now our cutoff is 3 minutes. So as we increase the time, all right, we are now starting to draw on glycogen for energy. But because this is still an anaerobic activity, in the absence of oxygen, that glucose cannot completely break down. So it's converted to pyruvate and can form lactic acid. As we continue to decrease intensity, we increase duration. Now we're going to an aerobic exercise. Our cutoff is, it's 3 minutes to 20 minutes. Now we can do complete breakdown of glucose. The pyruvate can enter into the mitochondria, go through a lot more reactions to produce a lot more ATP. And then finally, more than 20 minutes, that cutoff in the diagram, we now are drawing on fat stores. That's a lot of information, folks. But I want to know, I want you to have this. I want you to know it, especially for you athletes who hear that these low carb diets are the best thing, and athletes, the data show that the biochemistry is correct and that people who are on low carb diets are unable to perform for long periods of time because the lactic acid is building up. I'm sorry, that's wrong. They're unable to perform their high intensity activities because the lactic acid builds up, it fatigues the muscle, and they have to stop. Now, Justin, I saw you nodding your head. What do you think about that?
Oh, I just was nodding my head because I eat a lot of carbs, and I do so because of what you were mentioning, because I just it's nice to have carbs in you while you're working out. So I was just happy about that.
Well, one semester I had a student, when I talked about how this is the biochemistry, but for athletes and for those of you that are interested in the fitness part, this is how you use that information. And he was just shocked because he was telling me he and all his friends thought that the keto diet was the best thing. Is a bad pun since sliced bread. And I said, well, this chemistry, this doesn't lie. And so he said he was going to tell all his friends. And when he did, when he posted it on whatever y'all post things on, he said the word he got back was that it was fake news. It's not. This is what's going on in your body. So if you are training for an event, if this is something, if you are interested in fitness for whatever reasons, low carb diets notwithstanding, that's not the best thing for training. Now, one thing we didn't get to with this topic is about electrolytes and fluids, but we're going to come up to that again in Module 5. So I hope that we can review what's going on with the body during periods of extreme stress. The last question was address that issue, all right, that we sweat to get rid of the heat that our body's producing. We'll talk about a condition called hyponatremia, when you're replacing the fluids but not the electrolytes, and that can be fatal. Okay, and we'll talk about some other things when we get to that section, but I think that's enough. Yes, Justin.
I have one quick question.
Absolutely.
We mentioned that for the sweating, the sweat comes from the plasma in the blood. I read this a while ago, but I read once that saliva also comes from that. Is that true? That our saliva?
Why not? Why not? Yeah.
So gross.
Well, the body is gross. What can I tell you? Yeah. Now, I think I said in this other group, I mean, your body sweats And when you stop sweating and you continue to exercise, you're increasing that internal body temperature. All right. And one of the things that can denature proteins is heat. So it can be very dangerous. I remember watching a video of a marathon. I think it was a New York marathon. This woman was flailing across the finish line. In her desire to finish the marathon, she had stopped taking beverages that were being handed out to everybody. And she had stopped sweating. And she could have died because she was dehydrated. She was not sweating. Now, I have had students tell me they don't sweat. I don't know what to tell you if you're not sweating. You know, I don't know how your body gets rid of heat. You're very unique. I don't know how that works, but that's how our body gets rid of excess heat, is through sweating. What questions do you have? Because this was a lot of information in one day. All right, I'm going to let you think about it. And I have to give a talk this afternoon on the myth of detox. One of your questions that I was going to address today, but I wanted to do this, had to do with whether or not we need to detox. No. Your body is not a toxic waste dump that needs to take extraneous things to get rid of them. The only toxin I'm concerned about that metabolically is produced is that ammonia, which gets converted to urea. This is cocktail chatter now. And as long as your liver and your kidneys are working, then you don't need to detox. They're going to record this, and because I have time restrictions, I'm not going to get to cover everything, but that's what I will give for you for that topic at the end of the semester. So your detox questions, bring them with you, or certainly ask them sooner. Any other questions before I let you go? Okay. Okay. I was going to say, I think I might ask some more questions about this topic next week, but I think I won't. I think you have too much going on right now. I know y'all are really busy. So bye now. Thanks for your patience. I am not excited about my computer not cooperating.
Thank you, Professor.
Thank you.
Thank you.
Thank you.